All right, we're going to start again with the domain and range of continuous graphs and see if we can try it again with a new sheet and if it will be a little bit easier the second time. You'll notice along the top there is a sentence up here to help us that we're going to fill out together. When we're looking for the domain, now I don't have pink highlighter, but I do have a red highlighter that kind of looks pink. Remember that the domain is always your x values, and your x values are the ones that go from left to right. So when you're looking for the domain and you're looking for all of the x values that are included on a graph, you are going to scan your pencil left to right along the x-axis. If you scan your pencil from left to right, you'll be able to see all of the x values, all of the side to side, left to right, horizontal numbers that are used in making your graph. For the range, which you can highlight blue if you still need that note, that's all the y values. That is looking for, y values, remember, go up and down. So we're going to be looking for scanning our pencil, scan your pencil bottom to top to capture all of the up and down values, all of where those points lie on the up and down y-axis. Okay. If we can scan our pencil across and we can scan our pencil up and down, or if you want to use your colors like I'm going to, your pink and your blue, we'll be able to kind of get a better picture of what the values are that are included. So I'm going to move my page up and I'm going to be doing the odd numbers with you. You can try the even numbers alone and then check the key and see how you're doing. I'm checking number 1, and just like my directions tell me, I'm going to take my pink highlighter and I'm going to scan this graph starting from left to right. And actually what I notice is that it covers the entire graph from left to right. This picture goes all the way even off the graph. And all of these x values, so the x value of 0, 1, 2, 3, and everything in between, they're all being used. And it even goes off the graph, and it has these arrows that tell me that this goes on forever in this direction. So if it goes on forever to the right, and it also goes on forever to the left, that means that I really don't have any numbers along the x-axis. No numbers along here that aren't part of the coordinate pairs for this line. I have something along the 2, something along the 2.5, something along the 3, something along the 3.5. It captures every number. So my domain for this one is going to be all real numbers. The x values pretty much are infinite. They go infinitely to the left and infinitely to the right. On the other hand, when I look at my range, I notice that my range actually, which is my up and down now, my range actually begins right here. And if I go up, it starts at -2 and goes up. And it looks like it kind of will keep going up forever. If I follow the direction of this graph, it's going to keep going up and up and up and up and up, and also off to the side. Up and up and up and up and also off to the side. So what I see here is that even though it goes up forever and ever, I can't say that it's all real numbers because it does not go down forever and ever. There's a cutoff point, and that cutoff point for this particular graph is at -1, -2. I'm only focusing on the numbers up and down now. So I go to my origin, right? I'm actually going to move over so I can see better. I'm going to my 0, and I go down -1, -2. That's where this begins. There's nothing less than negative 2. There's nothing smaller than negative 2. That must mean that for this particular instance, my range, my y values, have to be greater than or equal to negative 2. My y value could be negative 2, but it could also move up to negative 1. It could move up to 0, to 1, to 2, to 3, to 4, and all the way up forever. Let's try number 3. So with number 3, we're going to use the same strategy. We're going to take our pink highlighter and we're going to go from left to right along our graph. And we notice right away that there's arrows, right, going to the right and to the left that say that this is going to be going on forever. So the domain, just like in number 1, the domain are left and right numbers that are included on this graph are all real numbers. Okay. There are no numbers along the x-axis that will not eventually be a part of all of the coordinate pairs on this graph. We can go all the way over to negative 100,000, and there will be part of the line there with a point. As I take a look at my y, my range, there's really no starting and ending for that either. It covers not every number on here yet, but if I think about it, this line eventually is going to go up here and probably hit positive 6 somewhere over here, and then it will keep going. It's going to go down and hit all my negative numbers. So it seems like with this one, because it goes up and down and left and right infinitely, that my range for this one is also all real numbers. Now looking at number 5, we've got sort of an enclosed graph here. This is continuous because it's all the dots are connected with lines. And what I'm going to be doing is I'm going to be focusing my attention on the dots that are the outermost dots of this shape, the ones that go the furthest left and right, and the ones that go the furthest top to bottom. These 4 dots are just 4 of the dots that make up this square on the graph, but they're the important dots because it gives me a frame of reference. Along the x-axis, I see that the dot that is furthest most left starts here, and then we move all the way here. The value of this dot is over negative 1. So my work in my domain begins at negative 1. As I scan over and over and over across my pink line, the furthest most right point is right here at positive 1, positive 2, positive 3, positive 4, positive 5. So my work in this shape ends at positive 5. So what I know is that my x values, all of my x values on this graph, are somewhere in between negative 1 and 5. And if I know accurately how to make my arrows for greater than less than, what I see is that my x is greater than negative 1 because the greater than direction goes to the right along the number line, but that my x also is less than 5 because my less than direction, if I look at 5, less than means it's over here somewhere in comparison to 5. So I've got my smallest value, my leftmost value here, my rightmost value here, and my x in the middle. X is greater than negative 1, x is less than 5. Now we've got a similar situation with the range. So we'll quickly look at the range. I'm going to go kind of off to the side. My range begins down here and goes up here. So the smallest value of my range is negative, oops. The smallest value of my range is -1, -2, -3. The largest value of my range is +3. And somewhere in the middle are my y values. My y values are greater than -3, but less than 3. So we've got a couple more to talk about here, number 7 and 9. For 7, I'm going to take a look at my left to right, and it's pretty obvious now that I've looked at a few, that if I move from left to right, it seems like this wavy pattern is going to keep going left and right to infinity. So right off the bat, I am going to name my domain as all real numbers. You're going to start to see that more easily the more that you do this. On the other hand, I'm noticing a pattern with my y values. If I just look up and down, the topmost point of my graph seems to be here, and the bottommost point seems to be along this value. And then there's obviously some points in between here, right? There's some points a little bit larger than this value, and there's some points a little bit smaller than this value, which means I've got to set up my inequality to show that I've got a highest point, a lowest point, and I've got a whole bunch of y values, a whole bunch of up and down numbers in between. So just like before, I'm going to start with my lowest point, which looks like it's at -1, -2, -3. The lowest y value I have is -3. And then the highest y value I have, if I start at my origin, is up to 2. My y is somewhere in between. My y is greater than -3, but less than 2. All my y values fit somewhere in between. Last, we've got this line that is straight up and down. So looking at the domain seems like it's a little bit confusing. What I really notice is that my domain is pretty much the same the whole way over. If I'm making this line on a graph and I'm thinking about my xy coordinate pairs, I always, always, always start at my origin and move over to +1, +2. +1, +2, +1, +2. Doesn't matter how far up or down I'm going, what my y value is, but I'm always moving over 2. So that means that my domain only has one number involved in it. I am always, always, always going left or right 2. Now my range, on the other hand, if you follow your range, has those arrows up and down and shows that your range is going to be all real numbers because your range goes infinitely up and infinitely down. Now on your own, go back and try the even numbered problems and then go ahead and check in with the answer key to see how you did and to see if this stuff is starting to make a little bit of sense to you.